If 2x square plus 3x plus 4 raised to the power 10 is equals to summation r from 0 to 20 ar x raised to the power r, then find the value of a7 over a13. You are watching Brain Explorers, the world where brain starts working. In the given question, AR means the coefficient of x raised to the power r in the expansion of 2x square plus 3x plus 4 raised to the power 10. We have to deal with A7 and A13. A13 is the is the coefficient of eighth term from the beginning, and A7 is the coefficient of eighth term from the end, and this is the condition which is helpful for us. Equivalent condition is that 7 plus 13 is equal to 20, which is helpful for us. In the expansion of x1 plus x2 plus x3 and so on up to xn raised to the power m, the general term is something like this. Later coefficient is x1 raised to the power m1 times x2 raised to the power m2 times x3 raised to the power m3 and so on up to xn raised to the power mn, where m1 plus m2 plus m3 and so on up to mn is definitely equal to m, and numeric coefficient is m factorial over m1 factorial times m2 factorial times m3 factorial and so on up to mn factorial. In our given question, we have a quadratic expression raised to the power 10. So let's take a general quadratic expression raised to the power 10. Using above formula, we can write the general term of this expansion also. So in place of m, we have 10. In place of x1, we have ax square. In place of x2, we have bx. And in place of x3, we have c. And there are only 3 terms. Also, m1 plus m2 plus m3 is equal to 10. But there is no need to use this coefficient as it is. The information that this is a constant depending upon m1, m2 and m3 is sufficient for us. Now let us see what is the term containing x raised to the power 7. In the expansion of ax square plus bx plus c raised to the power 10, there is not exactly one set of value for m1, m2 and m3 which gives us the term containing x raised to the power 7, but there are many such set of values. We will write each of them one by one. So for the first set, let the numeric coefficient is k1. And now take exponent 0 on ax square. Here ax square contributing nothing to make x raised to the power 7, so the whole contribution should be made by bx. Hence it needs a exponent of 7. Now 0 plus 7 is equal to 7. We need an extra 3 to make it a 10, because sum of exponents should also be equal to 10. For another set of values, let us take constant equals to k2. Take exponent of ax square as 1. Now ax square is making a contribution of x square. We need an x raised to the power 5 to make it x raised to the power 7. So an exponent of 5 is required on bx. 5 plus 1 is equal to 6, and extra 4 is needed to make it a complete 10. For another set of values, let the constant coefficient is k3. Take 2 as an exponent of ax square. Now ax square is contributing x raised to the power 4. We need x cube. So exponent of bx should be equal to 3. 2 plus 3 is equals to 5, and we need an extra 5 to make it 10. For another set of values, let constant is k4. Exponent of x square is 3. It is contributing x raised to the power 6. So exponent of bx should be equals to 1. Remaining 6 to make it a 10. Another set of values for m1, m2 and m3 is not possible to get a term containing x raised to the power 7, because if we choose m1 equals to 4, ax square will give us x raised to the power 8, which will exceed the x raised to the power 7, and that's why there will be no possible values for m2 and m3. So a7 is equals to k1 times b raised to the power 7 times c cube plus k2 times a times b raised to the power 5 times c raised to the power 4, and so on. Now to find the coefficient of x raised to the power 13, we will make some changes. We can write x square plus bx plus c raised to the power 10 equals to x raised to the power 20 times a plus b over x plus c over x square raised to the power 10. Taking the term containing 1 upon x raised to the power 7 in the expansion of a plus b over x plus c over x square raised to the power 10, then multiplying it with x raised to the power 20 gives us the term containing x raised to the power 13. Since to find the term containing 1 over x raised to the power 7, we will use exactly the same set of values of m1, m2 and m3 which we have just used to find x raised to the power 7. Therefore, the constant coefficients used in that expansion will also remain same, that is k1, k2, k3 and k4. Now multiply all these terms with x to the power 20, and we will find the term containing x raised to the power 13 in the expansion of x square plus bx plus c raised to the power 10. So a13 is equal to k1 times b raised to the power 7 times a cube plus k2 times c times b raised to the power 5 times a raised to the power 4, and so on. You can see that if in a7 we interchange a and c, we get a13. Now take the ratio of a7 and a13. You find that most of the portion is cancelled out and we get a7 over a13 equals to c cube over a cube. In our question, c is equal to 4 and a is equal to 2, so we get a7 over a13 equals to 8. In general, for ax square plus bx plus c raised to the power n, coefficient of x to the power m over coefficient of x to the power 2n minus m is equal to c over a raised to the power n minus m. This was our solution. Let's move to our another question. In a game, you have a cubic die numbered from 1 to 6. Initially, your score is 0. You have to throw the die again and again until you get a 6. Each time you get a number other than 6, it is added to your score, but if you get a 6, game ends. What is the probable score you can make? Try this question and send us your solution, and if you have any question like this, then please share with us. Don't forget to like and share our video, and for more such videos, subscribe to our channel Brain Exploders. Thanks for watching.